guys. We value you for you. You are someone as well. Oh, that's right. Start with 8.2. 8.2, number 4, identity. 8.2, number 8, -4, 9. Are you rocking it? Rocking. Number 32, final answer. -8 thirds, 2 thirds, 8 thirds, 0 4 thirds, -6.
Very cool.
Is that what you got?
Remember, you had to add the 4a, divide by 3, or divide by 3. It's okay, it's easy. It's a little mental math mistake. Or arithmetic mistake. Can I keep scrolling? 44, matrix multiplication. You could have checked with your calculator, right? You could have checked.
No, you do with the calculator.
Look at that.
Come on, Miss
They were nice.
All right, we'll let them be nice. They must have been nice too by assigning it. Okay. Dun, 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 dun.
Done.
Number 62. Ooh. You had to augment the coefficients with the constants, and you had to make it into an identity matrix. Final answer: -2 3/2, 3/2. Good practice.
Oh, come on.
Oh, sorry.
Close enough.
Typo. +2.
Oh.
Typo. You see it? Hold on. Let me do insert. Can I insert like a little lines in there? Shapes? Well, let me just put it in. Sorry, +2. Once again, could you have checked this with your graphing calculator by RREFing? Yes. You could reduce echelon forming anyway.
But do we get to do that on the test?
There's going to be a calculator, non-calculator portion. Well, you need to know how to use your calculator. That's good, right? So some of them will be really, really easy and fast. But some of them you might have to show. But guys, am I really going to make you like do more than one of these by hand? Luke says yes. The whole test. 5 by 5. Go. Just kidding. Some of you might like that though.
That would be
I
pretty
think I
crazy.
like it.
I'm just saying it's crazy.
Alright, section 8.3. Section 8.3. If you guys were wise, you would have kept the 1/4 out until the very, very end. If you guys were wise, you would have kept the 1/4 out until the very, very end. Because it's so much easier to do matrix multiplication with the nice numbers and then put the 1/4 in. I also did it the other way as well. Long story short, when you multiply A times B either way, do you always get the identity? And the answer is yes. So what is B? A inverse. Number 18, you were supposed to use the doubly augmented system, which means just RREF this side and see what happens. RREF that side, get it to the identity. What happens? You get 1, 1, 3, 4. Did we do that exact example? No. We did something with 1s and 3s and 4s, but maybe it was a little bit different. Here's your notes. Number 20. Woo! Doubly augmented 3 by 3. You guys really had to practice section 8.1 skills and 8.2 and 8.3. Number 20, work with the first column. You already have the established one. Get your zeros. P.S. If you guys are not solid on 8.1, we did just start in pre-cal today, 8.1. I am doing a much shorter, sweeter, simplified version for them. So if you want, if you're not solid with this whole by hand technique, you can go watch pre-cal videos. It's not a bad idea. I explain it a little bit differently, especially in section 8.1. I cut down their homework. I simplify the examples. So if you want, you can watch today and tomorrow. You can do it on double speed. Just get to the example and then you're like, okay, I'm going to slow it down and listen to what she says. I might example it, I might explain it. You're close. I might explain it in a little bit shorter, sweeter, cut to the chase, get to the main idea. I might explain it a little bit better. Because in honors, I go fast. Okay, number 40. Woo, look at those fractions. Go team. So you were able to use your shortcut formula, right? This guy times that guy ends up being negative 2 ninths. Minus that guy times that guy ended up being 15 fourths. But we had to get some common denominators. Then it's 1 over that number, or the reciprocal, times, switch the main opposite the opposite. Switch the 2 on the main diagonal, put opposite signs on the opposite, and then bring them in. I take either answer. You can leave it nice and factored, or you can put all the yuckiness in. And number 50 was our last one. You guys can check him out as well. The numbers were nicer, but a little bigger. You might have used your calculators to help you with that. Did I talk about in your class the nifty shortcut for multiplying big numbers without two-column multiplication using multiplying binomials yesterday? No? That was calculus, I think. In my Algebra 1 book, it's a new book, and I've been teaching them for the first time in a long time. But either way, it's a new book that we picked. How do you multiply without using two-column multiplication? 18 times 24. Didn't you have to do that? There are multiple ways to do it. But here's one fun way. At least I think it's fun. The Algebra 1 kids don't fully appreciate it. Isn't this 18 times 24? Why does that make it easier? What's 20 times 20? Then 4 times 20? And then minus 2 times 20? It's not totally mental math, but couldn't you maybe do 480, 440, 432 pretty fast without using ever two-column multiplication? Since you guys did get to 432, did you not get to 432? Right? 400 plus 80 minus 40 minus 8? No, it was not. Anyway, I thought it was kind of cool. So I'd probably rather do that than do two-column multiplication. But maybe you'd rather do two-column multiplication if you had to do it without a calculator. Alright. Anyway. Moving on. Final solution, 1/2, 1/3. Any quick questions on odds or evens? You guys just scared me. Nope, we're good? Alright, on A2 and A3, right? Sweet, let's get out of there. That's a yes. I thought you guys would have questions. I need to close down. I had like the book ready to pull up. Probably a good thing you didn't have questions because technology has not been liking me today. The computer's freezing. Wi-Fi is being sad. Notes open. We want to cover 8-4 all in one day. Let's see if we can do it. I have my calculator open just in case. Let's get rid of pre-cal notes. We don't need that open anymore. There. What'd you guys get as your final answer? Oh, no, Skylar, got it. Don't worry, I'm good. What'd you guys get as your final answer to this problem when you multiplied the matrices?
Oh, you guys are making sweaters for Cal? We should get a sweater for honors pre-calc.
Calc BC already got one like last semester because they didn't bicker about it. Calc AB bickered, then I broke my foot.
Yo, who's
So now we're
down?
getting it.
Yo, who is down?
Huh?
Who is down?
No.
No.
For honors
I thought
pre-calc?
AP was a little bit.
Usually.
Just kidding.
If I did an honors, then the other honors teachers would get mad at me because then their honors kids would want one, and then we
That's so
just,
true.
and the whole like only the highest kids get it, mid will be debunked. Because there wasn't any. Go ahead, debunk the myth. Anyway, wait, you guys are supposed to finish it. What'd you get? Did you not finish it? Am I gonna use my hand faster than you guys? No one else finished it? Only Sean? You guys are killing me. You were staring at this for like 5 minutes at the beginning of class.
Yeah, I was writing it down.
16 and 24.
You what? Okay, I know the first one was negative 16. Did I make it the second one? 24? What does that mean? Who was I solving for at the very beginning? X and Y. So I can say the final point was negative 1624. Is this a capital X or a lowercase x? Capital X. I'm talking about the variable matrix. If you want, you can name them something else, like, I don't know. Who do you want to make the variable matrix? Q? Okay. Q is has nothing to do with variable or matrix. Anyway, Q. Okay, since Q equaled and Q were the variables, then we can say, oh, we have to change this guy to a Q. So if you don't like using a big X, you can use Q. But the reason the book uses a big X is because X is known to be the unknown almost always, right? So this is not lowercase x, this is uppercase X, and I went ahead and put A and B, signifying the X and Y from the beginning equation. And then real quick, kiddos, why did I do this whole thingy at the beginning? What was I doing? Yeah, I didn't like my decimals, so I was like, hey, if I multiply everybody by 10, I move the decimal place to the right one, and that makes everything nicer. You could have multiplied the decimals if you really wanted to. Any questions on this one, since you guys did homework and theoretically it worked out? Okay. Section 8-4.
Oh.
Now it's going to get fun.
Uh-oh.
If I can remember all the notations for determinants. Off the top of my head, I only know 2 notations for determinants. Anybody have their book? We don't bring our books, do we?
Wow.
How do you say that on National
You go.
Book Day? It's
Oh,
actually
is it?
You go, Cosette.
That's so sad, Cosette, huh?
I'm sorry. Actually, I like that stuff. I just don't like hearing them.
I totally understand, don't worry.
You go for sure.
Everyone's feeling it. Hey, Brandon, since you're up, can you grab me a pre-count book? We were just lamenting no one having a book. Nice thing is, we just graded 8283. It's on the video, so we're just starting. We did just write this. So question, is this new? No, which is why I called it. Go team.
Nicole, let's try to read next time.
Oh.
Oh, man.
Oh.
Give her a look, Nicole. Give her a look. There you go.
I know. Those are you.
I do not endorse bullying. Okay, so. Playful banter is okay. It's okay, other people were thinking it, they just didn't say it.
I'm a nerd.
You know your word.
Yeah.
But wait, guys, it's still in the yellow box, which means it's still important.
That's right.
Main minus opposite. A few years ago, they called it opposite. I don't know why.
Wait.
It was main and opposite. Main minus opposite. The determinant of a 2 by, of a 2 by 2? That was only a determinant of a 2 by 2?
Oh boy.
What's the title? Determinants of only 2 by 2s?
No swear.
Woo! What size can a square matrix be? 3 by 3 or 4 by 4 or 5 by 5 or 6 by 6, and it's not a double but bigger.
Oh, and then also.
Square matrices. Hold on, I have to figure out my third notation for determinant. There's that, there's oh. Okay, ready? You guys have already seen, you can say DET of a matrix A. That's one way of saying determinant. Let me not put equals. That's one way. The other way is absolute value of a matrix A. It does not mean absolute value, it means determinant. We call it A bar, but that's actually something in statistics, and it's actually something like this. So that doesn't work. So for right now, we'll say the absolute value bar is around a matrix. It just means determinant again. The other way of saying it is you could actually put the entire matrix with each of its elements. This is the one I forgot. You could put him in absolute value, not brackets, and that means the same thing. So all three of those mean the determinant. And as we just pointed out, the only formula we know is how to get a determinant of a 2 by 2. When in homework they asked for the inverse of a 3 by 3, I think they had you do it the wrong way, right? That was on purpose because the formula only works with 2 by 2s so far. I'm recording, right? Yeah. Ready, set, next page, go. Mental math, you guys should be able to rock it because these are all 2 by 2s. I'm just going to go ahead and help us practice the new notation. So we'll say determinant of A, determinant of B, determinant of C. I'm freezing it, you guys go. How'd you do?
Uh-oh.
Wait a minute.
That B one is, that B
Oh,
one's
never
a
mind,
problem,
just kidding.
huh?
I don't know what I'm talking about. Keep going.
I don't know.
You see,
Sorry, too much fun, too much fun, too much fun.
I'm feeling tired.
but B is a problem.
It is a problem.
Man, there's a little bit of burns going on.
All right. Let's start throwing some sugar into this and salt.
Hide it.
Shoot.
Right? Does that work? They just hadn't finished writing it, so I'll hear it. All right.
Oh, I see it.
I'm showing the work. Is that okay?
Okay, I got it.
Luca is a little like, oh no, about letter B. How come? What is special when the determinant is 0? The determinant is 0. That's the answer for the determinant. Ooh, but it's singular, which means, I'll put it in parentheses, that's not the point of the question right now. But, since it's singular, what does that mean?
Is B singular? No.
Does that make sense?
That's definitely we just
Got it. Go team. B is singular, so no inverse. Yeah, you got it. Be proud. Ignore the haters. Actually struggle. Love the haters, right?
Yeah.
Sound it out.
How to remember.
Underrated. By the way, I think you guys were like
I know.
messing around.
Are we
with
ready?
the kids.
Oh.
Even
Is anybody else still ready besides people back here?
in the PKs, even like Arbella, like some people were just messing around like he didn't care. I was like,
Ready, set, go. Oh, wait a minute. Did it not go? There it is. Go, go, go. Zoom, zoom, zoom. P.S. At the top, it's A11, not AN, and not A11. Just making sure we're good. At the top, it's A11, not AN, and not A11. So now we're starting to answer the question. Okay, so we got the whole determinants of 2 by 2s down. Main minus opposite. Cool. So what if it was a simpler matrix? What if it was just a 1 by 1? It literally was a matrix with one element. What would be the determinant? Guess what? Almost. Itself. Oh, the determinant is itself. If it's a 1 by 1, the determinant is itself, is the one element, is the one entry. So for a 1 by 1, that is not the right blue, but I don't want to go find the right blue. That's okay. The determinant is the one entry. If you have a 1 by 1, the determinant is the one entry. It's itself. That's easy, right? A 3 by 3 is a little bit harder. And a 4 by 4, it's even harder. Now,
let's not.
for a 3 by 3, hold on. For a 3 by 3, there's actually a trick to it. And you might like the trick. The dilemma is the trick only works for 3 by 3s, not 4 by 4s, 5 by 5s or 6 by 6s. But it does maybe cut down the work for a 3 by 3. So I'm going to show you the trick for the 3 by 3, but then we're going to have to generalize and say, okay, but what's the actual method for solving for all determinants of any matrix higher than a 2 by 2? All right, here we go. The reason why is, real quick, all we've talked about is how determinants can help us find inverses, maybe a little bit shorter, right? But determinants are actually applicable in lots of different ways. Kind of like the dot product, we looked at it, we used it for like 1 or 2 things, and I said, hey, it's actually a big deal in physics. Kind of the same thing with determinants. We're going to look at it, practice the math involved with it, maybe apply it in 1 or 2 ways, but it's actually a big idea in linear algebra, which is a higher type of math. Ugh,
Do we have to rate this?
what's this? Expanding by cofactors. Do you guys want to see the cool shortcutting thing first?
Words.
Yeah, I mean, depends.
We'll do the shortcutting thing and then we'll come back.
There we go.
So let's go ahead and steal. Can we steal this exact same matrix? Where is he? Okay, write this guy down. Don't write anything else down. Write this guy down underneath the 3 by 3, and I want you to write shortcut off to the side. As you do, I'm going to go ahead and go back and put him in the notes where I want him to go. Write down just the example underneath the 3 by 3. I'll show you the shortcut for only a 3 by 3. 3 by 3 shortcut. Nope, just the circle thing.
Okay.
Now you guys got it? I need to write it down, then we got it. 0, 2, 1, 3, -1, 2. You could try moving over like one. I don't know yourself. Do you want to try it?
Okay, this is better.
It's better?
Because, like, it's
Yeah, no, I understand.
right there. Wow.
Sorry, that's all the nice looking
On
thing.
the couch and wake up in the morning when
Alright, ready, set, go! Ready for the shortcut?
Yes. So ready.
Question, if we were to do the 2 by 2, the main minus the opposite, would we hit everybody? No. So we can't just do main minus opposite, but you ready? We're going to rewrite the matrix. We're going to write it twice. Twice? We're going to write it twice. You can think about augmenting it maybe?
Why?
Don't worry, we're not row reducing. Calm.
Okay, I can relax.
Don't worry, we're not row reducing. Calm. Now, remember, when we just did main minus opposite, we didn't get everybody. But, check it out. Only for a 3 by 3. You could do main, getting 0 and 2 and 1.
Oh, I think I do remember.
And then do minus, let me do a different color, like, I don't know, what should I do? Green? Minus, opposite.
But am I still forgetting something?
Main minus opposite. It only works for a 3 by 3. The mental math there is you might not mind this because, ready, main. 0 times -1 times 1?
0.
0. Plus, all the means are positive, all the opposites are negative. Plus, 2 times 2 times 4?
16.
Plus, 1 times 3 times 0?
0.
Minus, now do you guys want to do minus or minus with a parenthesis and do it later? Okay. Minus. Opposite, 4 times -1 times 1?
-4.
Opposite, 0 times 2 times 0?
0.
And 1 times 3 times 2?
6.
We end up with 16 minus 2, right? Which is 14. Now hold on, let's be really, really cool and let's say, you know what? There is this thing called a calculator. And on the test, sometimes we'll be able to use it. So can we do a determinant of a matrix on a calculator?
Yeah.
How?
You go to section
Math.
matrix. You after you enter, you go to math.
This is a 3 by 3, right?
Every time you say 3 by 3, I think about like the burger,
I'm
the
sorry.
actual burger.
I've gone
It's a personal problem. That's good. What's the
Wait, how do I do a determinant?
What's the issue with the 5 by 5
Scroll down to the thing, is it there? The mapping thing? Hey, it's number 1! We're tracking, right? People in the front, we're tracking my little toppers.
Yes.
Look good.
Yes?
Wait, where are we going?
We know where to find determinant, right?
Determinant, yes.
Okay. Oh man, y'all.
Remember we make the matrix Brandon? So we go to our matrix and we make it, I edit it, and I make my matrix, I put in then math, you got it? Hey, were we right? Ready, set, and go.
I thought it was
It's all right, it's all right. The computer's not working. Isa, Luke, focus. I want to be nice. Okay, so. Woo, wait.
Oh.
Right away. Hold on.
I know.
Oh, don't be.
We're so hungry.
It's nutrition next, don't worry. All right, now we got it right. Okay, so go. If A is a square matrix of order 2 by 2 or greater, but we're never going to use it for a 2 by 2 because we have another way. Then the determinant of A is the sum of the, is the sum. Oh, this is just like the words of the math below, right? Because sum, isn't that what this means, right? Okay, so is the determinant, got it, is equals the sum of, those are all the pluses, the entries in any row or column, the entries, oh hey, these are entries, aren't they? Looks to be all the entries in row 1. But who are they being multiplied by? So all the entries in any one row or any one column, okay, so everybody in one row or one column, multiplied by, oh, they're next to, okay, their respective, who is this guy? I think we need to learn who those guys are, right? So we have something new. It's not totally wrong for you guys just to write the formula, as long as you're labeling stuff, like A sub 1, 1, A sub 1, 2, A sub 1n are going to be all the entries in any one row or column. You get to choose, and there will be strategic choosing. I promise. Words are not coming out right. All entries in any one row or column, you get to choose strategically. And long story short, the more zeros, the better. The smaller numbers, the better. C11, C12, those are those cofactory things we better learn how to do on the next page, and don't worry, we will. But guess what? Whatever entries you choose, you're going to have to choose cofactors based on the row or column. The same row or column as you chose for your entries. And otherwise, just multiply each corresponding one and then just add them all together. Done, determinant, that sounds easy. This whole process is called expanding by cofactors. This whole process is called expanding by cofactors. And that is how we find the determinant of anybody 2 by 2 or greater, but we're going to use it for 3 by 3 or greater. Unless you like the 3x3 shortcut or trick, then you'll use it for anybody 4x4 or greater. Unless the directions say you have to use this idea, this way. Alright, a couple more seconds because you guys are trying to get down as much or as little while still getting the main idea. We need to go figure out though what on earth are cofactors. I think we can do it in 10 minutes. We're going to try. What are cofactors? But in order to talk about cofactors, we actually have to talk about something else first. Minors. And not like the people. Like you guys. Not like that. It's not a bad thing to be called a minor. Alright, you ready? Set. We're answering the question, what are cofactors? But first of all, what on earth is a minor? Let's start here. Before we get to cofactors, let's talk about a minor. There's a lot of writing on this page, but then basically it's just practice, practice, practice. So, remember, we're answering the question 3x3 or higher. It is a bit more complicated, and we're figuring out what is a minor. A minor is the determinant of the matrix resulting from ignoring the nth row and the nth column, meaning to find the minor for the first row, first column. You go to the first row, first column spot, and you ignore the row and the column, and you just take the determinant of what is left. And what is the determinant of what is left if we were to actually solve for the minor? Oh, main minus opposite, -1 minus 0. So the minor 1 is equal to -1. Yeah, just because we're breaking down this example, if that makes sense. And how we break it down helps us understand what is a minor. So a minor is going to a spot, ignoring that row, that column that that spot is in or corresponding to, looking at the rest that's left and taking that determinant main minus opposite. Now, if this was a bigger matrix, you'd be looking at not a 2x2, but maybe a 3x3, and then you'd have to do it the long way. The nice thing is, if you can understand what a minor is, a cofactor is easier, or I should say is easy after that, because the cofactor just says, sweet, take the minor, what it equals, and either multiply them by a +1 or multiply them by a -1. Wait, well, how do you know which one? For C11, we take -1, and either we multiply them by a negative or we multiply them by a positive. And how do we know which? It's all dependent on alternating signs. Now, don't stress, you don't have to write all of these down. You don't have to write all of these down. My question is, what is the pattern? Start with a positive. The location that's being used to find the minor, hence the cofactor, the location being used has a corresponding sign. So we use 1, 1. And guys, in whatever size matrix you use, whatever's in the 1, 1 spot, we always start with a positive. So we multiply -1 by a positive, which means, well, negative times a positive is a what? Stays the same. If you have a positive in the space, stays the same. If you have a negative in the space, flip the sign. It's a crazy trick. Someone super smart came up with it, but it works. And to prove to you it works, I'm going to use what we now know is a minor, is a cofactor. Remember, he was the important one for the formula, not even the minor. The minor just kind of got us to this point. I'm going to use this idea in order to solve for the determinant of this matrix another way. You ready? Sign pattern. Remember, the pattern is start with a positive and then alternate. So a positive goes to a negative, goes to a positive, goes to a negative, goes to a positive, the negative goes to a positive, and a negative. They should alternate no matter how you look at it. No two signs are right next to each other. Does that make sense, guys? Yeah, you can think about diagonals. I was like, can't we just think of the main diagonal is all positives, all negatives, all positives, all negatives, all positives. We can think of it that way. They alternate this way too. All positives, all negatives, all positives, all negatives. However you look at it, it's okay. We're usually going across though for this because of the formula, so that's why we usually just think of it as a cross. Oh, stink. I don't want to use that one. Is this the one that we were doing? 0, 2, 1, 3, negative 1, 2, 4, 0, 1? Okay. Let's do this example and then we might have to do just a little baby bit of 8-4 tomorrow and then keep going to 8-5. So we didn't quite finish it. This homework isn't totally due tomorrow, but you guys can probably do a good bit of it to start it off. But we won't grade homework 8-4 until Monday. But we're starting 8-5 tomorrow. Okay, let's find this determinant. I see a 0 in row 1. So I'm going to choose, remember your formula for the determinant of A. The determinant of A equals, I'm going to choose row 1. So I'm going to do A11 times C11 plus A12 times C12 plus A13 times C13. Once you get the hang of it, you don't really need the formula. I'm just showing you why I'm doing what I'm doing. Okay? Who is A11? Who's in the first row, first column spot? 0. Who is 0 getting multiplied by? The cofactor, which comes from the minor of the element in the first row, first column spot, which means the determinant of the resulting terms. So 0 is going to get multiplied by, ignore the first row, ignore the first column, it's going to be everybody else. And that's what I wrote. But that's a minor. To make it a cofactor, we also think about, okay, hold on, 0 is in what spot as far as signs go? Who's 0? Nope, isn't he in this spot? Right? 0 is in that spot, so I assign a positive to him. Does that make sense? Okay. That's just A11 though. That's this term. This term is done. Plus.
What's C11?
C11, remember, he's the minor with the attached sign. He's the minor with the attached sign. So I attach the sign based on the table, right? And I steal the minor, and the minor just says, hey, ignore, ignore, take what's left. So I did. Does that make sense? Hold on, let me just finish the pattern. Maybe it'll make a little more sense.
Wait, how'd you get? I thought we got 14 in the other time. Oh no, but
I haven't done it yet. I'm
that
just
one's
showing you the
minor,
pattern.
not determinant.
Yeah, I'm just showing you the pattern. 14 was the overall answer, right? Yeah. Now I have a 2. I'm going to leave a little space because we still have to ask ourselves the question, stay positive or flip negative. I'm going to take the 2. I'm going to ignore the row and the column that he's in. I'm going to take everybody that's left, which means 3, 2, 4, and 1. Then I go ask myself the question, hey, what sign spot is 2 in? So I need to go ahead and not put a question mark. I need to put a negative. Or if you want, you can think, well, if I did positive of the one before, I can do negative with this one, right? So I can subtract. So I have 0 times what's left. I have 2 times what's left. It was a positive, now it's a negative. Or I should say it was addition, now it's subtraction. And then guys, what's going to be my last sign? Addition. Who's my, follow the pattern, who's my last one that I'm going to circle? 1. So 1's going to go in front. Who am I going to cross out? Row 1 and column 3. Who's left over? Now, how do I actually do this, though? Wait, upside down, oh no, up and down lines, don't they need determinants? What's main minus opposite? Well, that'll be 0 times negative 1 minus 0. Which I think think, are we good enough at mean minus opposite just to say -1 minus 0 is -1? Is that okay? Minus 2 times mean minus opposite, 3 minus 8. What's 3 minus 8? -5. Plus 1 times mean minus opposite, 0 minus -4 is 4. That just cancels out. -2 times -5 is 10. 10 plus 4 is 14. Dun, 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 dun. Got it. And kiddos, you would have gotten the exact same result if you had chosen any one row, that guy or that guy instead, and done the same process. Or if you had chosen any column, that guy or that guy or that guy, every single one of them following this pattern would have gotten the exact same answer of 14. Tomorrow we're going to do basically 2 examples and be done. We've already talked about the graphing calculator. Bye, cool kids. I'll see you tomorrow. Go enjoy nutrition. Go eat some food. Hopefully. If not, you can go beg for like a crumb from somebody else. Remember, spread sugar, not salt.